Welcome to this DaVinci Resolve Fusion node breakdown. Today's node is the particle render node. So we're going to jump into Fusion where we've got our setup we went over yesterday. And if you didn't check out yesterday's video, make sure you go to the description from yesterday's video and download this footage. And I go over how to set this up so we can use it in our particle breakdowns. And what we plan on doing is, as we go over our daily node breakdowns, we're going to add particles coming out of the back of our little jet bike here. But before we start, we're going to start talking about cleaning up some of this stuff, because once we start adding particles and more nodes, this is going to get chaotic. So we want to make sure we keep our nodes nice and organized. And I know I haven't gone over any organizational nodes yet, which I probably will right before we do 3D nodes, because we're really going to start getting a lot of stuff going on, and especially when we do 3D with particle nodes. So it's going to get super chaotic. But just to simply group these up, all we have to do is select what we want to group, right click on any of the nodes and hit group. And that just grouped all those nodes into one single little node. And we can hit F2 to rename it, and we'll name it footage. And all of our nodes are right here. And if you ever need to get back into the nodes, all you have to do is double click and you've got your node all in that little group. And to close it back down, you just hit this little X. And if you ever need to ungroup anything, all you have to do is right click and hit ungroup. So the particle nodes. Now there's two nodes you need for any particle systems that you're doing. And that's the emitter node, because you need something to emit, and the render node, because without the render node, you're not going to see anything being emitted. So in order to bring these in, we can hit our shift spacebar and search for them. Or if we go right up top here, we have our emitter node, we can just drag down, and we have our render node that we can drag down. And if you look, we see nothing on our render node, we see nothing on our emitter node, but once we connect them, we can see our render is showing our particles. And like I said, I'm only going over the render node today, and you may think it makes sense to go over both of them, but there's a lot of information in each of these and I want to break it down. And the reason I'm going over the render node first is this is just my workflow. So they're equally important. They need each other or they don't work. But my workflow is always going over my output first to make sure any output or any render, if I'm using Houdini or Blender, anything, I always make sure my render and my output is set up before I do anything else. Because if we come in here and make any changes and we're like, oh crap, we forgot to make this change in the render, it could possibly change everything up front. So I like to make sure our render or any output nodes are set up first. So that's why I'm going over the render node first. So as you can see, once we pop in our emitter and our render node, we can see what's going on in our display window. And let me go ahead and just fit this. And to navigate in this area right here, you click on your middle mouse button. So you can freely move it around. If I scroll up or down, it actually goes up or down. If I hit Control and scroll up and down, it'll zoom in and out. And if I hold Shift and go up and down, it'll change our angle of view. And that's how you navigate around this window. And if I push play, you can see we have particles beginning to emit. And in order to actually see what's going on a little more, I'm going to actually add some velocity in here so we can see what is going on. So those are our particles being emitted. Now on our render tab itself, and let me get back over here, we've got the ability to change our global in or global out, meaning where that is starting from. So just like footage, if I change my in point or my out point, it's going to change my in and out. Now the output mode just determines whether we're working in a 3D environment or a 2D environment. And since our footage is 2D, not 3D, it's 3D, but it's in the 2D layer system, we're actually going to work in 2D. In this entire node breakdown of all these nodes, we're going to be working in 2D first. And once I go over all the 3D nodes and do the node breakdowns for the 3D stuff, including materials and all that lighting and camera and all that fun stuff, then we'll come back in and we'll go over the 3D particle system because it is a little different. So right now we're going to keep it simpler and we're going to focus on the 2D. And you notice we just lost all of our 3D data, but our particle system is still there, operating the same, just on a 2D level. And in order to see this a little better, we're going to add a background, and we're not going to merge our footage in quite yet because I want to just put a plain black background here so we can work on our particle system, and then we'll bring it in and tailor it to our actual footage. So I'm going to bring in a background. There we go. So we can see what's going on with this particle system a little better. And let's jump back in our render node. Now your next option here, only render in high Q. This means right now we're just operating off of a point system. So no matter how we have our emitter set up, whether it's blobs or images or anything, it's going to render out point system so we can work on our look and all that stuff. If we put only render in high Q, it'll start showing all the effects that we have, like the specific types of emitter that we're using and all that stuff. But it's going to slow your system down. So for right now, while we're developing this look, we're going to uncheck this. Now this automatic pre-roll, this is why I didn't cover this yet. This automatic pre-roll means it's automatically calculating the frames because our particle system needs to know what happened the frame before to be able to create the particles in the next frame. So when we have it on automatic pre-roll, it's calculating everything behind it to be able to calculate this specific frame. So if we jump to this frame, it's going to say, hey, let me pre-calculate everything so I can see what's going on with this frame. Because if we don't, and I uncheck this, and let me go back to 0 and say I play that portion. I go to the next frame, and then the next frame, you can see it's barely moving because it's based off the previous frame that was rendered and not calculating all the frames in between. And if we have this automatic pre-roll off, it is faster if we're working on stuff, if it's bogging down your system. And you can always hit this pre-roll button to recalculate it up to that point. And you notice it didn't change, but it actually did. If I move this back and move it forward, you can see it actually changed. So what this automatic pre-roll is doing is anytime we push play or move our playhead to any location, it's automatically going to calculate all those particles before, so it's correctly showing what's happening. So we're going to leave automatic pre-roll on. Your view 2D is just basically the perspective you're viewing it, whether it's the scene, the front, the top, or the side, and we're going to leave it in the scene. And down here under your controls, we have blur, glow, and blur blend. Now these are only available in the 2D mode, and even if we switch back over to 3D mode, which it won't because we've got this merged into a 2D element. And let me show, if I disconnect this from our merge, now we can show our render in 3D view again. But if I attempt to connect this output to a 2D merge, it's not going to let me because it's expecting 3D pipeline, which we haven't gone over yet. We will, but we haven't. So I'm going to switch this back to 2D and reconnect. And now we're connected back up to our 2D layer system. So this blur, what the blur does is it's going to add a blur, just like any other blur, to your particles, to your point particles. And we can change our glow to make them glow. And we can change the blend. Now, this blur and this glow is exactly the same as if we just added blur and glow afterwards. So a lot of times that's a better option. So I like to just leave these off and worry about any blurs or glows on an independent node level. And also, if we don't have any blur going on, you notice our glow doesn't function at all. So it's technically not glowing, it's only glowing that blur. So if we brought it up, you can see it's glowing. But we'll switch that back. For your integration method, this is kind of some math nerd stuff. It's whether it's working off the Euler or the Runge-Kutta 4x method, and it's just math, how it's calculating. I always leave it on Euler. For your subframe accuracy, this is just how accurate your subframes are, and it will change the look of your particles. So as we are creating our particle system, we may jump back and forth just to see how our subframe accuracy is doing. But now, the more accurate you make this, the slower it's going to be on your system. So in the initial stages, I tend to leave this down to just 1. And as I'm adding stuff and really need to see how my look dev is going, I'll start raising it a little more to see how that's looking. Pre-generate frames, we will definitely be using this. And what this does is it pre-generates your simulation. So if we go back to frame 1 and let's connect our footage. On frame 1, we should already be seeing our little jet engine particle system coming up. We don't want it to slowly start playing and then go like she just started because she's already moving. So what this pre-generate frames does is we can pre-generate our particle system to say, hey, go ahead and calculate all that stuff this many frames ahead and start from there. So now our particle system will start right there. Instead of starting at frame 1, creating our particles, then moving our particles, it's already in the system and ready to go. And this will take into account any additional stuff we put in here, like turbulence or directional forces or anything we put in. But for now, we'll move that back, reconnect our background. Annoying sometimes. So on the render node, now you've got this kill particles that leave the view area, which is great because technically any of these particles that are going out of the view area are still living. So that data is still kind of being generated in case these particles need to be reused. If we kill the particles that leave the view, anything once it passes our domain of definition, it's going to kill the particle. For what we're doing, this is fine because we're not going to have any particles coming back in. But if, say, we were creating dust or anything that would blow back into our scene based off of a force that's off screen, if we were killing our particles, there would be nothing to reintroduce into the system. So you would make sure you uncheck kill particles if you have some type of force that's blowing your particles back into your scene. But we're going to leave kill particles on because it does help our memory a little bit. This generate Z buffer, we are going to use this, but I'm going to leave this unchecked while we're doing our look dev because it's generating data and it's generating Z buffer data, which is amazing because we can use that Z buffer data as depth of field stuff or fog or any other thing we need. So it's great information to have on anything. If you can generate Z buffer info so we can use it down the pipeline. But initially, we don't need this while we're doing look dev. It's just once we have our look and we want to go down the line and start making changes, we definitely want this generate Z buffer back on. This depth merge particles, this basically means we're going to use depth merge instead of layer-based blending. So right now, if I go to my merge button and I go to my channels, we have this option for depth merge. And this is currently just doing layer-based blending. So if I go up here and hit depth merge particles, I can now go into my merge node, click enable depth merge, and now I can use this button to bring those particles in at a different Z depth. And this is useful when you have a large particle system with some particles up close to the camera, some particles far away, and you want to do different effects or different things with those depth merge. This is what you would do to be able to manipulate any of those particles on different Z levels. But we're going to turn this off, and let me reset that just in case. And we are not going to use depth merge particles for this part. So moving to the scene tab, under the scene, we have a translation where we can translate on the X, the Y, and the Z axis. And let's reset those. We have rotation, and you can change your order of your rotation, and I tend to leave it on X, Y, Z. And this just changes your order of rotation. And you do this a lot of times to match different 3D programs, because different 3D programs have different orders. But you can rotate on your X, your Y, and your Z axis. Now your pivoting, these really don't come into play until we start using 3D cameras, because it will do pivot operations, but you can see if I move this up to 1,000, it's really not changing much. It is, but it's so, you can't tell it's changing. But once we start introducing a 3D camera into our renders, which is what this green input is for, is your camera input, we'll start seeing some differences in this pivot and a lot of these zoom perspective, Z clip, and focal length. Well, focal length works in 2D as well. So we're gonna zero these all back out. And your zoom, you can zoom your footage, but as you can tell, it's really not operating very well. But once we connect a camera, it does. Your perspective will change your actual perspective, so we can bring it up close and get into the actual particles. Your Z clip will change the Z clip once you start bringing that into, say, a camera. And let me bring that back down. So if I change my perspective up close, this Z clip will allow me to clip off some of these particles that are closer to our camera. But you notice it's really not working very well. It's pretty finicky. And again, once we bring in this camera, this will operate a lot better. And we've got our focal length, which is set at 35 millimeter. And we can change our focal length up or down. But we're going to leave that zeroed out as well. On our grid tab, this is supposed to create a grid, kind of simulating our 3D grid. So if I disconnect this, our little 3D grid that's going on there, we can see that. And under the 2D, it's supposed to create a grid, and it used to. But for some reason, it's not working for me right now. And I tried to troubleshoot it and figure out why my grid isn't working, but it's not working at all. So let me know if yours are working fine, or if there's some new crazy button on the new updates of the particle system nodes, but it's not working for me anymore. But this would create a grid that you could use to kind of line your stuff if you need to. I honestly really never use it, but it's there. Under our image tab, we have the ability to change our process mode. We've got like full frame NTSC fields, the PAL HD fields, but we're going to leave it on full frames. We also have the ability to change our resolution, and right now it's set in auto resolution, so it's just using our project resolution that we have. But if we uncheck this, we can change our resolution. And I may not have shown this to you guys before on other nodes with this resolution options, but if you right click on either the width, the height, or the pixel aspect, if you right click, it gives you options that your system can handle that are set up on your system to change. So like if I need to change my resolution to 4K, I can just click 4K digital camera and just give me 4096 by 2160. instead of our 2048 by 1152. So that's there, as well as pixel aspect ratio. Or you can just click auto resolution and it'll set it up for your resolution. And we have depth, which we can use to set our pixel color depth. And I usually use this on default, but you can change it to whatever you need. Now our color space down here, these don't actually change your color space. And auto, what it's doing is just kind of picking up what's coming through the pipeline. But if we need to push metadata from our render out to say we want this to be considered an ACES color space, even though it's not actually changing our color space, it's pushing that data through. So anything we add to it is going to treat this as ACES color space. So it's just pushing that metadata. And you can pick whatever you want. And I usually leave these on auto. And same with your source gamma. So you've got auto, you've got space, and you can select what space you're in. And you can select log, which is similar to our Cineon log node that we went over the other day. And then we've got the options to remove our curves altogether and pre-divide and post-multiply. And I'm going to leave this checked. Under our settings tab, we have the standard settings. I do, however, kind of want to hit this motion blur in here because it's going to give you an error. Well, not an error. It's going to give you a warning. And just to kind of know that even though this is adding motion blur, it's letting you know it's not going to compound the motion blur on different nodes. Meaning it's going to process this motion blur just within this node based off everything that's coming in. And the actual warning, if you check that, you can read the warning. It says motion blur controls can be connected to other tools, but any animation will be ignored. So I tend to leave this unchecked and add my own motion blur later when I need my motion blur. And a lot of people assume that we can just go to our merge node and select motion blur and it's going to blur, but it's not going to operate that way. You just have to remember this motion blur on your merge levels. The only thing that this is applying motion blur to is anything that's actually moving on this level. Meaning if I take our entire layer input and move it back and forth, it's going to apply motion blur to that specific movement, not necessarily what's happening within our footage. I hope that makes sense. But jumping back in, and we've got all the other typical apply mask inverted, multiply by mask in our settings. And as far as input goes, I mentioned this is our camera input for our 3D environment when we start going over 3D stuff. And this is an input mask effect. And all this mask effect does is if I want to bring in a mask, I can mask it out. So that is the particle render node. Tomorrow we're going to jump into our emitter node and we will start doing our look dev and creating our emitter for our little particle jet streams coming out of our bike. So I will see you in the next node breakdown.